Notice that these two representations of fractions have pieces that are different sizes. When you are finding the denominator, the bottom number, the denominator is the number of total pieces in the whole. In this case, the number of total pieces in the whole is 3. For this fraction representation, the number of total pieces in the whole is 4. The top number, your numerator, is the number of pieces that are shaded. In this representation, there is 1 piece shaded, so it is 1 out of 3. In this representation, it is 2 pieces that are shaded. 2 pieces, 1, 2, out of 4. Now, when we want to add these fractions, we have a problem. The pieces are not the same size. Before we can add them, we need to convert them into the same size fraction. To do this, we're going to use the giant 1 strategy. So, we're going to take 1/3 and 2/4, and we're going to turn them into pieces that are the same size. To do this, we need to find a common denominator between 3 and 4. To do this, we can either use multiples or multiply. To do multiples, we would look at a times table, and we would go 3, 6, 9, 12, 15, 18, 21. And then we would look at the other denominator, 4, 8, 12, 16. And we see that the lowest common denominator is 12. So we're going to convert those into a fraction with a denominator of 12, because this is the breaking up of these pieces here to make 12 pieces. To do that, we're going to use our giant 1 strategy. 3 times what number gives you 12? The answer is 4. And that means every one of these pieces is going to be split into 4 pieces. 1, 2, 3, 4. And if we change the bottom number by changing the total number of pieces, 1, 2, 3, 4, 1, 2, 3, 4, we also have to change the top number, because we no longer just have 1 piece that's shaded. We have to change it by the same number. So we use our giant 1. 3 times 4 gives us 12. So we make a giant 1, and 1 times 4 gives us 4. How many do we have? 1, 2, 3, 4. Now we have an equivalent fraction with the same size pieces. We'll do the same thing over here. For these pieces, use the giant 1 strategy. 4 goes into 12 how many times? 4 times 3 is 12, meaning that each piece gets split into 3 pieces. And 3 over 3 is 1. Giant 1, 2 times 3 is 6. Because the bottom number changed, the top number has to change as well, which means each of these pieces gets split into 3 pieces. And we multiplied the 2 times the 3 to get the 6, because we started with 2 original pieces. And each of those pieces was split into 3 pieces, 1, 2, 3, 1, 2, 3, so we have a total of 6. Now we can go ahead and add the fractions, because our pieces are the same size. So now we're going to use the giant 1 strategy, only we're not going to write out the giant 1 strategy. We're going to do the 3 questions. Do I need a common denominator? The pieces are not the same size, So I need a common denominator. I could do multiples. 3, 6, 9, 12, 4, 8, 12, 12, 12 is my common denominator. Or I could do multiply. 3 times 4 is 12. And this time, instead of doing the giant 1, I'm going to do 3 goes into 12 how many times? 3 goes into 12 4 times, which means each of the original pieces is divided into 1, 2, 3, 4 pieces. And I only had one piece, so 1 times 4 is 4. In this case, I have 4 goes into 12 3 times. Each original piece is split into 1, 2, 3 pieces, and I had 2 pieces, so 4 goes into 12 3 times. 3 times 2 is 6. Now my pieces are the same size. I can add the number of pieces. 4 plus 6 is 10. And how many total pieces are in a whole? 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 12s. I'm not quite finished yet because I need to reduce, meaning that there's a number that goes into both 10 and 12. This time we're going to use our giant 1 in reverse. Instead of multiplying, we're going to divide by a giant 1. So what number goes into both 10 and 12? And that answer is 2. 10 divided by 2 is 5, and 12 divided by 2 is 6. And my final answer is 5/6.